All right, we're back this time for laminar flow. And instead of creating a whole new one, since the mesh is the same and the geometry is the same and the results part is the same, really the only part you got to change is the setup. What I'm going to do is we're going to right click in Fluid Flow Fluent and we're going to duplicate it.
And this is just an easier part of it.
So you don't have to do it all over again 3 different times. And now we're going to wait for it to duplicate. Oh, she's all the way at the bottom.
She's down there.
So we're gonna just double click on setup and it's gonna be a double precision. Again, the mesh is and geometry are the exact same as in the first video. So we don't need to go over that. And we're gonna wait for it to open.
I forgot mesh is so long.
All right, the setup opened, and for models, you're gonna go into it, double click the viscous and viscid. Instead of viscid, this time we're doing laminar. I'm just gonna hit OK. And so now it's changed. And then everything else should be the same, except we're gonna have to change a few things. First of all, in the air, we're gonna change the viscosity. I think it was
1.8.
I believe I changed it to 1.8 to the -2.
I think so.
Hold on.
We have checked.
All right. I double checked because I forgot. So we made the viscosity 1.8 times 10 to the -2. And so we're going to change that. The density is still 1, so that's fine. Can close out of that. And then we're going to go to boundary conditions, inlet, velocity inlet. And we ended up changing the velocity at the inlet to 0.6 meters per second. And with that, and then the viscosity as 0.018, you get a Reynolds number of 33.3 repeating. And that should be good for the boundary conditions. We're just going to double check the wall. Actually, no, there is stuff to change. You don't have to change it, but it automatically comes as a stationary wall with no slip condition, which is what you want. So you're going to apply that, close everything out. Check the reference values, double, triple check.
Make sure they're updated.
Let's see if it'll update. Oh, it did. All right. So it updated the velocity and the viscosity for us, and you're going to keep that compute from the velocity inlet and the reference zone is the surface body. And we'll go into methods. It's going to be the exact same.
Simple, presto.
Presto. It'll be the exact same as the first one. And then
results, residuals.
Those are the same too.
They're the same from the last because we copied it over.
Yep. And then we're going to initialize, double check that it's still 25 iterations.
Good.
Get out of there and then initialize it.
A lot of the setup from this one was just making sure that when it copied over, it stayed. Sometimes the numbers like to change.
That and then just fixing the viscosity and the velocity so you can get a good Reynolds number.
Yep.
For laminar flow, it needs to be under 500,000. So we're doing pretty extreme values, if I'm being honest, but it's just to show the difference between the two clearly for laminar and turbulent.
Yes.
And so that initialization's done. We're going to run the calculation, calculate that. We'll see in a little bit. All right, we're back. It calculated.
It was a while.
It was like 5 minutes. Hello. All right. So now gonna do the exact same thing as the last one. We're just gonna go into the XY plots, and they're already here since they're saved from the last one. So we're just gonna plot that. And this one looks a little funny.
And it updates, but yes.
But it is supposed to look like that. This one's definitely not as symmetrical. It weans off as you pass the top of it. Yeah, it's the top. As you pass the top, it just kind of. And so that looks all good. We're going to close that, and then we're going to open up the velocity profile, plot that. And you can see it's straight 0 because it's plotting the velocity on the wall of the cylinder, and due to the no slip conditions, it's just going to be 0 for the whole thing all the way across. And so that looks good. And then we're going to go back to report definitions, click on this one. We're going to compute it, and then we're going to close it. And you get a pretty big drag coefficient, but it looks good because there's a lot of drag when it comes to laminar flow. And so now you have all those definitions. You're going to save, exit out, and wait for it to exit out.
Yep. And then we're back here.
Yep. And then you're going to go right into results.
Right.
And just give it a minute to load everything. And when you get into results and everything loads, it's actually going to have all the contours and the streamlines already from the last one. As you can see, it loaded in with the streamlines, so we'll just do that first. This is what our velocity streamline looks like. As you can see, it looks a bit different. You can visibly see the wake region right in the back end here. And you can also see that wake region in the contour. You can see it pretty well. It's going to be that sort of dark blue region. That's where there's no real velocity.
Yes.
We'll put the legend back to show that that dark purple-ish is 0.
0.
And it's just 0 right in there. And so that looks good. And then we can turn off the velocity contour and the streamlines. We'll turn on the pressure contour. And see, this is what the pressure contour looks like. It's kind of similar to the velocity one. And you can see the wake region right on the back end here. And that's going to be everything for linear flow. And save that. And we'll see you for turbulent.